In this video, we are going to solve some multiple choice questions. So let's see first, if the equation 4x square plus 2hxy plus y square is equal to 0 represent two coincident lines, then h is equal to. Here, the given equation is 4x square plus hxy plus y square is equal to 0 represent coincident lines. We know that the condition of coincident line is h square minus ab is equal to 0. So first compare the given equation with homogeneous equation of degree 2, that is comparing this equation 4x square plus hxy plus y square is equal to 0 with ax square plus 2hxy plus by square is equal to 0. Then by comparing, here a is equal to 4, 2h is equal to h and b is equal to 1. Here this h is equal to h by 2. A is equal to 4, b is equal to 1. So we know that the condition of coincident line is h square minus ab is equal to 0. Then by substituting this value, value of h is h by 2 bracket square minus a into b, that is 4 into 1 is equal to h square upon 4 minus 4 is equal to 0. So from this equation we get h square minus 16 is equal to 0. Then h square is equal to 16 and therefore h is equal to plus or minus 4. So here option is plus or minus 2, plus or minus 3, plus or minus 4 and plus or minus 5. And we have to find h is equal to, and our answer is h is equal to plus or minus 4. So correct option is C, plus or minus 4. H is equal to plus or minus 4. Let's see the second example. If the lines represented by kx square minus 3xy plus 6y square is equal to 0 are perpendicular to each other, then k is equal to. Here the given equation is kx square minus 3xy plus 6y square is equal to 0 are perpendicular to each other. The lines containing this equation are perpendicular to each other, and we know that the condition for perpendicular line is a plus b is equal to 0. So first compare this equation with homogeneous equation. So comparing this equation, kx square, comparing this equation kx square minus 3xy plus 6y square is equal to 0 with homogeneous equation. So comparing this equation with homogeneous equation, ax square plus 2hxy plus by square is equal to 0. Then by comparing, a is equal to k, 2h is equal to minus 3 and b is equal to 6. So the condition for perpendicular line is a plus b is equal to 0. Here a is k and b is 6. So k plus 6 is equal to 0 and therefore k is equal to minus 6. Now let's see the options. K is equal to 6, k is equal to minus 6, k is equal to 3 and k is equal to minus 3. Our answer is k is equal to minus 6. So the correct option is B, k is equal to minus 6. Let's see the third example. Auxiliary equation of 2x square plus 3xy minus 9y square is equal to 0 is. We know that the auxiliary equation of homogeneous equation of degree 2 is bm square plus 2hm plus a is equal to 0. So first here compare the given equation with homogeneous equation and find the value of a, h and b. So first comparing the given equation, 2x square plus 3xy minus 9y square is equal to 0 with homogeneous equation ax square plus 2hxy plus by square is equal to 0. Then we get a is equal to 2, 2h is equal to 3 and b is equal to minus 9. And our auxiliary equation of homogeneous equation is bm square plus 2hm plus a is equal to 0. Now substituting the value of a, b and h, then we get the auxiliary equation of given equation. So here b is equal to minus 9. Substituting this value, minus 9m square plus 2h is equal to 3m plus a is equal to 2 is equal to 0. Now multiplying by minus sign, then we get 9m square minus 3m minus 2 is equal to 0. And the correct option is B, 9m square minus 3m minus 2 is equal to 0. Here auxiliary equation of this equation is 9m square minus 3m minus 2 is equal to 0. So the correct option is B. Let's see the fourth example, the difference between the slopes of lines represented by 3x square minus 4xy plus y square is equal to 0 is. The difference between the slopes of lines represented by this equation. So first find the separate equation of this homogeneous equation. So by factorizing 3x square minus 4xy plus y square is equal to 0. By factorization we get 3x square minus 3xy. Factors of 3 into 1, 3 is 3xy minus 3xy and minus xy plus y square is equal to 0. Then taking 3x as a common, x minus y minus y into x minus y is equal to 0. So the first factor is x minus y, common factor x minus y, and second factor 3x minus y is equal to 0. Here we have to find the difference between the slopes of lines. Now the separate equation of given equation is x minus y and 3x minus y is equal to 0. So the first equation is x minus y is equal to 0 and second equation is 3x minus y is equal to 0. We know that the slopes of lines is given by minus a upon b. So here a is 1 and b is minus 1 in the first equation of line. So the slope of x minus y is equal to 0 is, using the formula minus a upon b, here a is coefficient of x and b is coefficient of y. So 1 upon minus 1, that is minus 1 upon minus 1 is equal to 1. Slope of x minus y is 1 and slope of the slope of 3x minus y is equal to 0 is minus 3 upon minus 1, that is plus 3. And we have to find the difference between the slopes of lines represented by this line. So here slope of first line is 1 and second line is 3. Second line is 3 and difference is 3 minus 1. Difference of slopes. Difference of slopes 3 minus 1 is equal to 2. So the correct option is A. Here correct option 2. 2. Difference between the slopes is 2. So correct option is A. Now let's see the next example. If the two lines x square plus 2hxy plus by square is equal to 0, make angles alpha and beta with x-axis, then find the value of tan alpha plus beta is equal to. Here two lines represented by homogeneous equation make angles alpha and beta with x-axis. So the inclination of these lines is alpha and beta, and so by using the formula, slope of lines is tan alpha and tan beta. So first here we consider the slopes of lines whose inclination is alpha and beta is slopes of lines are tan alpha and tan beta, and also the slopes of lines represented by m1 and m2. So m1 is equal to tan alpha, slope of first line, and m2 is equal to tan beta, which represents the homogeneous equation of lines. Now here we have to find the value of tan alpha plus beta. We know that the slopes of lines are given, then the sum of slopes m1 plus m2 given by minus 2h upon b, and product of slopes m1 m2 is equal to a upon b. That is tan, here m1 is tan alpha plus m2 is tan beta is equal to minus 2h upon b, and product of the slopes tan alpha into tan beta is equal to a upon b. And we have to find out the tan alpha plus beta. We know that the formula of tan a plus b. Here applying this formula, tan alpha plus tan beta upon 1 minus tan alpha into tan beta. So by substituting the sum of the slopes, that is tan alpha plus tan beta is equal to minus 2h upon b, and 1 minus product of these slopes is a upon b. Now simplifying this, we get minus 2h upon b upon, taking cross multiplication, b minus a upon b. Here b, denominator b will be cancelled, and minus 2h upon, taking minus sign as a common, then we get minus a minus b. Here minus sign will be cancelled, and we get 2h upon a minus b. 2h upon a minus b. This is the value of tan alpha plus beta. 2h upon a minus b. Correct option is 2h upon a minus b.